Welcome back. Today we are going to do 5.3, which are graphs of rational functions. A rational function is a function that is a ratio and has a variable in the denominator originally. And or the numerator. We are going to be looking at this today, and sometimes your variable in the denominator may cancel out, but is still a rational function. So to graph rational functions, we need to talk about points of discontinuity. So up until this point, all the graphs we have done have been continuous graphs. That means I could draw the graph without lifting my pencil. So since a rational function contains variables in the denominator, then the graph is going to contain points of discontinuity. These are points where I would have to lift my pencil up to start somewhere else. So there are two types of points of discontinuity that we are going to look at. We are going to look at the non-removable points, of discontinuity, and these are things that would make numbers that would make my denominator 0. We are going to use vertical asymptotes for this. So anytime my denominator is going to be 0, I'm going to draw a vertical asymptote. Remember, these are red dotted lines. Okay, all of our asymptotes are always done in red and they're always dotted. That a graph approaches but does not touch. The other type of discontinuity we have is a removable point. Of discontinuity, and these are canceled out factors. So when I cancel out a factor, that's going to create a hole in my graph. So a hole is a canceled out factor that create an open point in the middle of your graph. Now the thing you need to be careful of, whether you use Desmos or your graphing calculator. Your graphing calculator, unless you go to the table, is not going to show a hole, and neither will Desmos. So this is something you have to do algebraically to know where to put it. So when graphing rational functions, you will have to find some specific characteristics. You are going to have to find all of the asymptotes. And these are going to include your vertical asymptotes, remember, which we abbreviate as VA, and horizontal asymptotes, which we abbreviate as HA. And all of your asymptotes will be dotted lines, and remember, yes, whether they're vertical or horizontal, they need to be in red. Next, we're going to go to our intercepts. And these include my x-intercept, and these are both points, so we are going to write them as points. So the x-intercept will be some number, comma 0. And the y-intercept, which will be 0 and then some number. And finally, the last thing we're going to look for are holes. And these occur when any factors cancel out. And these on our graph will be graphed with an open circle. So if a rational function has one vertical asymptote, my graph will be in two parts. Sometimes it will have two vertical asymptotes, which mean my graph will be in three parts. So the next part, I'm going to spell out exactly how we find all this information. So how do we find this information? For vertical asymptotes, these are going to be x equals lines, and we're going to set the denominator equal to 0. Sometimes we'll have to factor it, but then we're going to solve for x. Horizontal asymptotes are going to be y equals lines. This, we're going to look at the degree. So you're going to find your degree of the numerator and the degree of the denominator. If it is bigger on bottom, your horizontal asymptote is y equals. If the degrees are the same, you are going to use the ratio of lead coefficients. And if it's bigger on top, you're going to put none. Your x-intercept, you are going to set the numerator equal to 0. Sometimes, again, we'll have to factor and solve. Y-intercept, it is the ratio of the constants. And make sure if you have simplified and factored things out that you then go back and multiply that problem out before you find your constants. And finally, our whole, these are our canceled out factors. So we're going to set our canceled out factor equal to 0, solve for x, then plug that x back into the reduced function, that's after I canceled it out, and get my y value, and that will give me my xy point. So let's look at our examples. If I look at example 1, first thing I always look is there something I can reduce to cancel out? Okay, now everything is divisible by 2. But reducing it by 2 on top and bottom isn't going to do me any good for canceling out variables. So I'm going to just leave it alone. So the first thing, vertical asymptotes. The direction said set my denominator equal to 0. So I'm going to say 2x minus 4 equals 0. I'm going to solve it. So add 4, divide by 2. My vertical asymptote is y equals 2. This is going to be a red dotted line on the graph at 2. Make sure when you write your equations for asymptotes that they are equations. Okay, looking at horizontal asymptotes, this is where we find our degree. So I'm going to actually write it down. I'm going to write degree of numerator and degree of denominator. So the degree of the numerator, let's look at the top. There is not an x there. Since there is no x on top, the degree is 0, because the degree of a constant function is 0. Degree of the denominator. So I look at x. My highest power of x is 1. Now I'm going to compare them. So I'm going to say since, how do I compare 0 to 1? 0 is less than 1. Since it's bigger on bottom, it's going to be y equals 0. Again, it is the equation of a line, so I need to make sure I put y equals 0. I'm going to make a horizontal red dotted line on y equals 0. Next, we're going to do our intercepts. So the x-intercept says set the numerator equal to 0. Can 4 equal 0? It cannot. So there is none. There is no y-intercept or x-intercept. If you have none for any of these things, you need to put none. If you leave it blank, I'm going to assume you didn't know how to do it. My y-intercept is the ratio of the constants. So on top I have 4. On bottom it's -4. Remember, your constant is the number without the x. So I write this as a point. It's 0, -1. I'll come over here and draw that point. And since I did not cancel out any factors, I do not have a hole, so I put none. From here, I only have 1 point on my graph and 2 asymptotes. That is not enough information for me to be able to graph these. So let's take a look what we need to do next. So there are 2 places we can go to help us get more information from our graph. First, we can use Desmos. So if I use Desmos, I'm going to type in y equals, and then I'm going to hit the divide key so it gives me my fraction. 4 over 2x minus 4. So as you can see, this is my graph. So, and if I hover over points, it will give me the point. So I need to find a couple more points. So I have the point, if I click on it and hover, it's going to get me close to the value. So at -2, it is -0.5. If I look at some of the other information, at 1, it's at -2. So that would be enough points for me to go ahead and graph that bottom half. But I also have this top half. So at 4, it's at 1. At 6, it is at a half. So Desmos won't give me a table of values, but I can use the cursor and try to hover over points or click on the graph to get some points. Now let me show you how to do it in your calculator. So if you have a graphing calculator, you will want to go to the y equals, and we are going to type, using parentheses, the numerator in one set, and then hit divide, and the denominator in another set. You could also use your fraction bar, but if you do, when I go to my table, it will give me fractional answers instead of decimal answers, and since I'm graphing it, Decimals are usually easier to deal with. So from here, to get my table of values, I go second graph, and now I can find some points on my graph that are easy to graph. So I have -2, -0.5, I have 0, 1, I have 1, -2. I have 3, 2, 4, 1. And I have 6, a half, 6, and then a half. So either of these you can use to get yourself some extra points to graph. So let's go back to our paper. So here was my paper, and you can see I've already plotted the point 0, -1, but I also said I had -2 and -1/2. I had 1, -2. Now that's enough points to give me an accurate graph, along with my asymptotes. So I will connect them. Make sure you are plotting your points, and make sure you're using your red lines as guides. They're going to come close to it, but never ever cross. And you definitely need the points, especially where your asymptotes cross, so you can figure out how close or how far away your curve is. I also had the point 6.5. I had the point 4, 1, and 3, 2. And there's our graph. Let's take a look at the next one. So again, with the number 2, there is not anything I need to factor out. So I'm going to start with the information. So vertical asymptotes, set the denominator equal to 0. So x plus 1 equals 0. Therefore, x equals -1. And go ahead and put that on my graph using a red dotted line. Okay, next we go to the horizontal. So this is where we look at the degrees. Degree of the numerator is 1. Degree of the denominator is 1. Since 1 equals 1, we are going to do ratio of the lead coefficients. Remember, these are the numbers in front of the letter that gave us our degree. So in this case, it would be y equals 3 over 1, which is 3. So the equation is y equals 3. So I'll put a horizontal line at 3. Next, we do x-intercepts. Here we set the numerator equal to 0. So that's 3x plus 6 equals 0. 3x equals -6, and x equals -2. We will now put that as a point. So it's -2, 0, and we'll put that point on the graph. My y-intercept is ratio of the constants. So on top that's 6, on bottom 1, so that is 6. I'm going to put the point 0, 6. And finally, there are no holes because there was nothing I canceled out, so I'm going to put none. From here, you would go to Desmos or your calculator, get a couple more points. And once you do, you will make your curve. And there's our graph. Now let's try one where we do have to factor and cancel something out. So we can take a look at what our whole is. So first thing I need to do with this first one, or number 3, is I need to factor the top. When I factor the top, I get x minus 4 times x plus 1 all over x minus 4. So notice the x minus 4's cancel out, and that leaves me with x plus 1 over 1. So for vertical asymptotes, I set the denominator equal to 0. 1 cannot equal 0, therefore there is no vertical asymptote. Horizontal, we look at the degrees, and we are always coming back to this reduced function. That's where we're getting our information from, not the original. So my degree on top is 1. My degree on bottom is 0. Since 1 is greater than 0, I have no horizontal asymptote either. Okay, so let's look at our x-intercept. I have an x-intercept, so I have x plus 1 equals 0. X equals -1. That means I have the point -1, 0. Let's put that on our graph. Next, we look at our constants, which is 1 over 1. So that is the point 0, 1. I'm going to plot that on my graph as well. From here, I had a hole, so I need to account for it. So where was my hole? My hole occurs at x minus 4 equal to 0. So that gets me x equals 4. I must now put this in my reduced function. Okay, this right here to figure out what my y coordinate is at that point. So y is going to equal 4 plus 1 over 1, which is 5. So I have a hole at 4, 5. So I'm going to come over to my graph, and at 4, 5, I am going to put an open circle. From here, I could go to my graph if I needed more points or if I just wanted to see what it looks like. In this case, it is a straight line because x plus 1 over 1 is simply x plus 1. Therefore, it is a line with a hole in it. So I take a ruler and connect my points and draw my line. And let's move on to the last one. So first things first, I need to factor. And on the bottom, you'll notice I have a cubic. I don't know how to factor a cubic, but I do know they all have an x in common, so I can factor that x out before I factor into 2 parentheses. So on top, I get 2x minus 1 times x minus 2. On bottom, I need to bring along that x I factored out, and I have x plus 2 and 2x minus 1. So I can cancel out the 2x minus 1. That leaves me with x minus 2 times x plus 2. That is my reduced function. But I also need to take that and multiply it back out. So you have to simplify all the way, getting rid of all parentheses. Because sometimes we'll use the factored form, sometimes we will use the multiplied out form. you need both. So vertical asymptotes, I'm going to use the factored out form because it saves me a step. If I use the multiplied out form, I'd have to factor it. So I have 2. I'm going to set x equal to 0, and I'm going to set x plus 2 equal to 0. So I have a vertical asymptote at 0, and I have a vertical asymptote at -2. And I'm going to put both of those on my graph. Next, let's look at horizontal asymptotes. Again, for this, I'm going to use my multiplied out one. So I'm going to have the degree of the numerator is 1. The degree of the denominator is 2. Since 1 is less than 2, it's bigger on bottom, so that is y equals 0. So I'm going to put a horizontal line at y equals 0. Next, x-intercepts, I set my numerator equal to 0. So I get x equals 2, so that's the point 2, 0. Now, normally we have thought of our asymptotes as lines that graphs approach but do not touch. Sometimes, and very rarely, but sometimes, they will actually cross over a horizontal asymptote. So when I plot this point and see that it's on a horizontal asymptote, that's okay. It's just going to hug the opposite side of the line. But know that sometimes that happens. So for my y-intercept, again, I'm going to use the multiplied out form. So my constant on top is -2. My constant on bottom is 0. Remember, anything divided by 0 is undefined. Therefore, I do not have a y-intercept. And finally, my whole. I set my canceled out factor equal to 0. Solve it. And now I'm going to plug that in to my reduced function. So that would be 1/2 minus 2 all over 1/2 squared plus 2 times 1/2. And I'm going to use my calculator to get a number, and it's -1.2. So from there, I am going to write that as a point. So I have a hole at I have a hole at 0.5 and -1.2. And since I'm graphing it, it's okay to write it as a decimal. So at +1/2, I have a hole right about there. That is really enough points for this right side of the graph, so I'm going to use those 2 points along with my asymptotes to go ahead and make my curve. Then I'm going to use my table function on my calculator to get some extra points. I'm also going to take a look at what the graph looks like. This has 3 parts. If you look at the graph on your calculator or on the computer, you'll notice this in-between part is kind of like parabola shaped. Now I was still able to plot 1 point and then just use the lines. I need some points over here. And again, use my lines to help me get my graph. That is it for 2-3. If you have any questions, let me know.